In this video, we're going to start to take a look at how we can calculate the area of composite shapes. With the example on the left-hand side, I have a regular hexagon. The hexagon has a total width of 16 centimeters and a height of 12. Although you can derive the formula for the area of a hexagon, we don't actually need anything more than the basic formulas in the video that I'll link here. Because with this regular hexagon, I can actually see two trapeziums, and if I can calculate the area of one trapezium, I can double it to then give me the total area of the hexagon. But in order to be able to see the dimensions of the trapezium, I also need to be able to see that there are 6 equilateral triangles here. If the total width of the hexagon is 16, the width of one triangle is 8. If the total height of the hexagon is 12, that means that the total height of a triangle is 6. And this is because the width of the hexagon is 2 triangles wide, and the height of the hexagon is 2 triangles high. So now I have a few options. Either I now know that the length of the parallel lines of the original trapezium are 8 and 16 and a height of 6, so I can calculate the area of one trapezium and then double it. I can also just work out the area of the equilateral triangle and times it by 6. I can then use the basic fact that the area of a triangle can be worked out by a half of the base times by the height. So substituting in the information I've got for one triangle, a half of 8 times by 6. A half of 8 is 4, and times it by 6 is 24 centimeter squared. I now know that the area of one triangle is 24, but I've got 6 of them, so the area of the hexagon will be 24 times by 6. This gives me 144, and because the original dimensions was measured in centimeters, the area will be centimeters squared. Pause the video here and have a go at the question on the right hand side. When you're ready for the answer, press play. So we're going to answer this question in exactly the same way. We're going to divide the regular hexagon into 6 equilateral triangles. If the whole width of the hexagon is 12, the base of the triangle will be 6. And because the height of the hexagon is 10, the height of the triangle will be 5. The area of one triangle can therefore be worked out by a half of the base times by the height. And substituting in the information, a half of 6 times by 5. A half of 6 is 3, and 3 times by 5 is 15 centimeters squared. Because I've got 6 of these equilateral triangles, the area of the hexagon will be 15 times by 6. This gives 90, and because the original dimensions was in centimeters, the area will be centimeter squared.